guys. So 4.3, we're pretty much finishing up the graphing part of it. So let's take a look. So we have, hopefully you can actually see it clearly, but you guys have the chart, so it should be no problem. Summary of y equals x minus k, x minus h squared. So if you have that, the vertex will be h comma 0. Remember, anything added or subtracted at the end, that tells me the y value of the vertex is always a 0. Inside of the brackets, I have the value, and for the x value of the vertex, that's just the opposite sign of the inside here. Now, since we have h comma 0 as the vertex, x of symmetry will be x equals h. Direction of opening is, now we have positive in the front. There's no negative sign in the front here, so it is up. Domain always x such that x is an element of real number. Range is y such that y element of real number. Remember, y value of the vertex, now it's up, so y is greater than or equal to. X-intercept is a bit tricky, but I told you how to find it, and you guys copied and you guys did it fine in the class. Now, as a shortcut, the x-intercept will be basically h comma 0. Okay, the y-intercept will be 0 comma h squared. Description will be horizontal translation, either left or right by h units. Okay, or you can say just move left or right by h units. Now, minimum or maximum value, well, we have up, so we will have minimum value, and we can say at 0 or h comma 0. When does it occur? When x is 0, or you can say h comma 0. Now, sorry. Now here's the thing. Now the graph, well, graph can be having this as y equals x squared, and then it can move this way. So this is when h is greater than 0. Moving this way when h is less than 0. Okay. So, having said that, let's do the summary of the overall. So we have summary of y equals now a x minus h squared plus k. So the vertex will be h comma k. Axis of symmetry will be x equals h. The direction of opening is up for a equals 0, and down for a is less than 0. Okay. Domain always the same, x such that x is an element of real number. Range is, now depends, okay, it can be y such that y is greater than or equal to k. Y is an element of real number if a is greater than 0. Or everything the same but less than or equal to if a is less than 0. Okay. Now the x-intercept portion is the tricky one and most interesting part of it. So remember, if it is x-intercept, then, well, the y value has to be 0. So it is, excuse me, plus minus square root of negative k over a plus h comma 0. Now this is very confusing in terms of generic format, so I really want you to give it a try by putting 0 into y and solve for the x with the actual examples that we did together. Okay, if you're just looking at the generic form, it's extremely confusing. Okay, now for the y-intercept, it's pretty much the same thing. It is a 0 comma ah squared plus k. Okay, so it's confusing if you're looking at the generic form. That's why I want you to try the actual examples. Okay. Now description is for A, we do two things, either reflection on the x-axis, okay, 2, vertical stretch, or compression. Okay, now everyone knows how it works, so you should know how it works. Now, and also remember, this one always follows up by a factor of. Okay, so if it is a stretch, then we simply just use vertical stretch by a factor of A. If it is compression, then we say vertical compression by a factor of 1 over A. Okay, so the vertical stretch is when absolute value, just the value of the A, is greater than 1, and compression will be the other way, less than 1. Okay. Now then we have H, so then H will do just one thing, which is horizontal translation. So I'm just going to put horizontal translation, or move left or right, okay, by H units. Lastly, K is now either vertical translation or move up or down by K units. Now, maximum value or minimum value, so if it is max, then A is less than 0. If it is min, A is greater than 0. Now, it always occurs at the vertex point anyway, right? Oh, no, sorry, H. Now, the graph, I'm not going to go into this, okay? Graph can be anywhere pretty much. However, what happens is this or that, or the upside down, doesn't really matter. This is always the vertex point, okay? And then I'll just put, remember to use 1, 3, and 5. And you know what I mean by 1, 3, and 5 by now, okay? You should know 1, 3, 5 and what it means. If you don't know, you have to try harder. Okay, that's for 4.3 summarization. Okay, all right, so see you for, in 4.4.